Okay, thanks everyone for joining this session. So today I'm going to talk about the stream or segments, best way to access the events in Pulsar. So basically, this topic is more related to the Pulsar architecture and the Pulsar's data abstraction provided to users on how to access the events in Pulsar. First of all, let me introduce myself a little bit. I'm currently a StreamNative software engineer, and before joining StreamNative, I was working at Twitter, working on the real-time streaming team with Kasik and Sanjeev, and I contributed a lot to the Heron project as well as the Pulsar project. I'm in general interested in event streaming technologies. Before we dive into the details, I would just go over, have a quick review of the Pulsar history. So when Pulsar was first created, or we call it Pulsar 1.x, it was purely a messaging system with stream storage supported. So if we look at this graph, it has multiple language client support like Go, Java, C++, Python, and underlying it was using the BookKeeper as a low latency storage for serving the messaging needs. And so in that time, like a one sentence summary would be Pulsar is a flexible PubSub messaging system backed by the durable log storage. And since the Pulsar 2.x, we enhanced the Pulsar a lot in every aspect. For messaging, we introduced like Pulsar IO framework and also the change data capture stuff. And underlying for the stream storage, despite the original BookKeeper storage, we also introduced a lot of cloud native storage, which is used as the tiered storage layer. And besides these two enhancements for the existing part, we also introduced a lot about the processing field, which includes interactive queries, which like Presto and Hive, and the stream and batch processing for Flink and Spark. And also the unique thing we provided is the function processing, which is the Pulsar functions. So now, like for 2.x Pulsar, we call it a cloud native messaging and event streaming platform. So some of the use cases Pulsar offers is like unified event center and bus, billing service, push notification, worker queue, login pipeline, IoT. Also, and the last one, which I'm going to talk about based on, is the streaming first unified data processing. For data processing with Apache Pulsar, so we offered like a lot of options for, as we just mentioned. Here, it requires a lot of integration. But before we dive into that, we would like to have a summarize for each of the data processing's characteristics. Here, we can categorize those data processing jobs in general into four categories. The first one, or the well-known one, is the batch processing. So the batch processing, the amount of data it processes is usually very huge and can run huge clusters with like hundreds of nodes. And also it provides fine-grained fault tolerance features. And as the industry developing, people with the need for processing real-time data or get results in real time, people or engineers provided the streaming data processing tools. And for the streaming jobs, it usually require usually has a long running jobs, always running for days, months. And it was very time critical. So usually the latency for a streaming job will be on the millisecond, will be like at millisecond level. And also the scalability is also a huge requirement, as well as fault tolerant. And then somewhere in between, we have interactive queries, interactive data processing. These kind of job has also a time critical requirement, but not as strict as streaming jobs. Usually it's a minute level latency would be fine. And the data size will be median and should rerun on failures. I think what Jerry just shared, Pulsar SQL would be Presto would be typical example for the interactive query stuff. And also the last one, like with the new concept of serverless computing, and we think that's another category we have here. We need to support. It's usually like for serverless, it will be simple and lightweight processing with the event-driven feature and processing data with like very high velocities. So for these four different characters, data processing needs. Now let's look at how Pulsar's architecture or Pulsar's design to support those kind of type of jobs later. So the first one is Pulsar. We all know that Pulsar is a layered architecture. It comes with two layers. The first layer or the front layer is stateless serving with brokers. So a producer produce data to brokers, and then consumers can consume data from brokers. And underlying beneath the stateless serving layer, we have a durable storage layer, mainly like backed by BookKeeper. So all the streaming data, all the incoming data will be first written into any bookies, and then it will be available in the broker's cache and then serve the consumers. So with this broker layer, stateless broker layer, we offered the Pulsar messaging API in general. So we can, with these messaging APIs, we can read data from brokers and with different subscription modes. And also the operations we usually include like consume, seek, or receive. And in order to reprocessing those kind of data, you can just rewind the cursors in the system, and then you will be able to consume from that point on. In terms of the subscription mode, currently Pulsar has like 4 different modes. Because we have exclusive subscription, in which like only one consumer will be able to consume a Pulsar topic. And if any other like consumers trying to subscribe to the new topic, it will just get errors and be failed. And we also have like failover subscription model, in which like only multiple consumers can subscribe to the same topic, but at any time there will be only one active consumers actually consuming data. Others will just be in a standby mode. And in case of the failures of the main consumer, then there will be another one be picked as the active consumers. This somehow can be used as a leader election model. And we use that in the implementation of Pulsar functions in order to find the man scheduler to scheduling function jobs for users. And also we have like general shared subscription model, which like every consumer is the equivalent, and they can consume data from the topic, maybe in a round robin fashion. And the last one is about the key shared subscription model. So in this one, it's like for every like message with the same key, they will go to the same consumers. So this is kind of something like needed by the integration with Apache Flink. So after we discuss about the messaging API, so we also have a layer of segment APIs. So for which like we can read data directly from the storage by passing the brokers. The storage usually will be BookKeeper or tiered storage. And for this segment API, it provides a very fine-grained parallelism, and also with some predicate pushed on like publish timestamps to further accelerate the performance. So the reason why we can provide this segment API is because of Pulsar's like a segment-centric storage. So for each topic partition, or for each topic, there is actually a logical abstraction called managed ledger in Pulsar to store all the events from the very beginning of the topic creation and until now. So and that's a storage layer for a single topic partition. And in this managed ledger, there is actually a lot of different physical ledgers stored in Bookie, or we call that a segment. So for each, whenever a ledger reach a certain amount of size, or it or it like exceeded some kind of time, or there is some kind of failures happens and the broker failed, a new ledger will be rolled up and will be stored in the bookie, and then a new ledger will be created. So for the ledger or segment, there will be a single writer and it's append only. And also there will be a lot of replications replicated to the multiple bookies based on your configuration for the bookkeeper cluster. So if we look at the graph here on the right side, you will see that for topic 1, part 2, partition 2, we have a lot of segments like segment 1 and 2. And as the time goes by, and each of the segments will be stored in stored with multiple replicas in underlying bookie nodes. So with this segment-centric storage, we are able to provide the above segment APIs, and also beneath the beneath the bookkeeper layer, we also provide the tiered storage functionality, for which you can offload your segment from the bookie to any mature industrial storage systems like S3, GCS, or Hadoop file systems. And for S3 and GCS, we use Apache JClouds to provide the support. And for tiered storages, we offers long retention time for all your data. So basically, you can store your data indefinitely without any limit. And also, the cost will be much lower than just storing plain data in your bookie nodes. And also, it will be very easy to access. The segment APIs will provide you the ability to fetch data from those storage and as well as from the bookies at the same time. So after explaining the messaging API, the segment API, the layered structure, and we can view the graph in here. It's like for the messaging API or for real-time use cases, the broker is providing the data for users or for consumers, and for historical data and for large scale data analysis jobs, the segment API will provide access to bookies and the tiered storage systems and send you the segments you need to access data. So with these architecture and APIs available, so now we can abstract the whole event streams in Pulsar. As this graph shows, we have infinite event stream storage. So for very old data, segments, we can store them in the tiered storage systems. Here we have S3 or GCS and Hadoop. And for most recent data, we have them available in the brokers. And for any data in between, we will have them in bookies. Okay. So now if you look at how people are reading consuming data from the topic, it will be within each topic, we might have multiple topic partitions. And for each of the partitions, it actually consists of different segments. And as we learned from the previous slide, the segment may be in the tiered storage, maybe in the bookies, and also it may be in the brokers. Depends on how mature the segment is, and if the consumer or producer is interacting with one partitions, it will be just to interact with the most recent segment. And for any other reading request, we will fetching data from the older segments stored in different places. Yeah, so this is example illustrating here the producers and consumers are actually appending data or consuming data from the latest segment, which is segment 6, and there will be a segment readers for others to consume historical data for existing segments. Okay, so what's the benefit for the architecture and for those APIs and abstraction? So the first one would be it offers an unlimited topic partition storage. So basically, you don't need to, your data storage capability is not limited by any of the nodes in your existing systems in the bookies. So basically, the data is stored as segments in different places. As long as like there will be more bookies available, you will be able to store the partitions, so the data of your partitions at will. And another benefit, not huge benefit, would be instant scaling without any like data rebalancing. So in broker failure recovery case, the brokers, as we know that it's stateless, so it doesn't actually own any data. It just owns a topic. So whenever a broker is broken, it's not responding, or it's have some problems, all we need to do is like for any consumer or producer, they switch to another broker, and the new broker will be updated and own this topic or own this topic's partition. And you will be starting fetching data from the underlying storage bookkeeper system. And for any like failures in the bookie, like disk failures or node failures, we can also do recovery with the replications. So any like, and also the recovery would be at not only like node level, but also like at the segment level or even data entry level. So for whenever a segment is not available, the bookie will automatically recover from the other like replicas and serving the data to the up layers. And also it will be very easier to expand your cluster horizontally. You just need to, whenever the application need like search traffic comes and you need to add more nodes, you just need to like independently add broker instances or add bookie instances based on your actual needs. And whenever those instances or nodes are added into the system, they will be immediately started to be used or serving traffic or storing data storage. So as also, we providing a low latency messaging API for reading data, which is very critical for the streaming or for the serverless use case. And we also provide high throughput and reading for batch data. This will be benefiting the data processing, batch data processing, and interactive data processing category. And also the last one is like the cost for storing. The cost for storing this whole data is kind of largely reduced. Okay, so here is kind of a Pulsar SQL case, which has a large dependency on the segment APIs we have. So basically, since we store data in the segment fashion in the storage system, so a Presto cluster, with the help of Pulsar Presto connector, they can, the workers can like fetch data in parallel from the storage system with a high throughput and generate the result for the users. So, and also for Pulsar Flink case, for normal like Flink job here, it's for the Flink job 1, it will be usually like only like using the messaging APIs to consume the latest data available in a topic or in the partition to process data. And sometimes if during like a Flink job recovery or checkpoint or catch up, then you will like utilizing both. Before you catch up with the latest messages, you will just be utilizing the segment APIs to fetch segments directly to like do the replay and construct all the states they need. And for like Pulsar functions, it will be mostly likely the Pulsar Flink cases, I would say. So as the conclusion, like Apache Pulsar, it's a cloud-native messaging streaming system, providing it also with the multi-layered architecture, and it has the segment-centric storage abstraction. And also with the 2 levels of reading API, PubSub plus segment, we're able to like fetch data from Pulsar based on our different data processing needs. And it also, with all these available stuff, we provide a unified view of data and with a lot of benefits as we mentioned previously. Okay, so here's some links about the Pulsar community, and a lot of interesting things are happening. So if you're interested, just check any of them and join in the community. Okay, so I think, yeah, I have finished my talk very quickly. So maybe we can, yeah, so that's all I want to share with you guys today. So.
Awesome, thanks so much, Neng. We can open up the session now for Q&A. If there are any questions. I think you covered everything, Neng, if there are no questions.
Okay.
Yeah, well, thanks everyone for tuning in for this session. We did wrap up this one a little bit early so we can send everyone out for a break and reconvene for the next session. The next session is going to be at 12:20, so we have about 20 minutes before Devin Bosk presents. He's going to be presenting on the Pulsar architectural patterns for CI and CD automation and self-service. If you guys do have any questions that do come up for Neng, please just feel free to join the Apache Pulsar Slack channel and we can get you guys connected. Thank you.
Okay. Thank you, everyone.
Thank you, Neng.
Mm-hmm.